This semester, our team was put on the Wavebreaker Technologies project. The team was tasked with taking an existing idea and developing a manufacturing plan that would allow for the product to be mass-produced while keeping the ability for scalable production. Wavebreaker founder and CEO Kevin Harris designed the inaugural product, the Day Tripper. It is an innovative drywall that attaches to the front of the user's kayak and is designed to be an easy-to-reach area to keep the user's gear dry. The Day Tripper is also designed to divert water around the user, keeping their lap dry. The Wavebreaker project consists of three main deliverables. The first is the design and manufacturing process for the Day Tripper that decreases the manufacturing time while allowing for scalable production. The second is to create simulations demonstrating the product and its water diversion features. And the final deliverable tasked to the team was creating IP drawings that conform to USPTO specs while allowing for the granting of a provisional patent.
We met with a team of lawyers from the Penn State Law Office to understand what they need from us for the patent drawings. We made the drawings in SolidWorks to send into the lawyers for their review. We had many cycles of going back and forth with them to get the drawings to the desired specifications. We then officially submitted 30 different drawings with multiple views and models to the law office. Simulations were run on variations of the Wavebreaker in order to ensure that it would divert water away from the opening of the kayak and allow our sponsor to showcase the effectiveness to potential users. Our sponsor's initial manufacturing process was to melt down the plastic as seen in the picture above and then bend it into the desired shape of the Wavebreaker. This manufacturing process was not efficient and it took many days to complete, which was problematic for his turnaround period.
We determined that casting a two-part urethane foam would allow us to significantly speed up the manufacturing process and reduce the material cost per product. Furthermore, two-part foam casting allows us to avoid requiring any expensive equipment that would put a strain on the finances of our sponsor as a new business. We engaged in weeks of research to determine that this was our best option and to rule out a number of other, more commonly used processes as non-viable for meeting our sponsor's needs. In order to cast the foam, we determined the silicone molds were our best option. The high reactivity of urethane foam gave us very few options, and of those, silicone was the most cost-effective. Silicone also provides the flexibility to make demolding of the product incredibly easy.
In order to have a repeatable casting, we used a 3D printer to build a positive that follows the silicone process previously explained. This 3D print will be used to mold the silicone. The silicone will then be used to form foam that will be used for the final casting. The final assembly of the product can be seen above, where all hardware and installation will be done by hand.